The same delay for your airbag to open, it's not there, right? So this is the difference. So when you press a play button for your music, if it delays for 1 second, nothing bad is going to happen. Yeah. But if the airbag opens after a second, we are facing some problems.
Yes, yeah. You're right, but I think times changed already, because waiting a second is quite not acceptable today. In the following, my conversation with Melvin Francis, actually the second discussion I had with him about networking, network technologies, future trends in that topics, and all the stuff around it. We were going into details about real-time application in industries, and Melvin is one of those special guys which really try to test the stuff, which build test setups, which try to do networking in real time over wireless connections, and not only talking about it. That's a special thing, I think. If you like that channel, just subscribe and have fun with my discussion with Melvin Francis. Melvin.
Hello.
Nice to meet you again. Second time talking about network stuff, actually. Yeah. Last time we were talking about TSN. Mm-hmm. So can you give us a quick overview of what we were talking about?
Yep. So first of all, thanks for coming back to us. And I think this is the second time. And in the first video, we discussed a lot about TSN and how TSN augments with OPCUA, and how OPCUA plus TSN can be one of the best candidates for the industrial automation world. And seeing your video, we got a customer request, and then that valid customer request, they changed into a paying customer for us, which is really great. And we are happy that we had a valid query, a customer request generated from your video, and it adds a lot of value to our company as well. So thank you so much, first of all.
That's awesome. That's great, actually. Mm-hmm. So as you told me beforehand, working together with that company, it's, for example, about controlling a robot arm via TSN and using OPCUA PubSub, actually.
Exactly.
So what are the main ingredients, or were the main ingredients for?
Yeah, so the customer had a problem statement. So they had a robot which is controlled with their own proprietary technology. So what happened was they wanted to sell their robots to different companies, but the communication protocol was the problem. Like they were not aware of, they were coming from a different world. And when they come into industrial automation world, they wanted to make their robots work with the existing PLC controllers. So there they wanted to explore the legacy Ethernet protocols, and seeing your video, they came to us asking for some suggestions like X protocol, Y protocol, or Z. And then they came to know about OPCUA TSN as well. And then we had some workshops, we had some discussions and architecture and network design. And then they came to know that OPCUA TSN would be very good, because one protocol from sensor to cloud, and it surely matches their requirements. So OPCUA FX is what they are looking for, and we have already started the developments for them. Mm-hmm.
So OPCUA is some global standard, actually, and right now people use it in most of the time in the non-PubSub variant. PubSub is meant to be for real-time purposes, but as far as it concerns me, most of the people don't look at PubSub using TSN, especially not because TSN is so far away. What is the reason for that? Just to still wanting to drive that robot arm using OPCUA, PubSub, and TSN.
So just to talk a little bit of history. So OPCUA was primarily used for huge machines, and it's not used for real time. So once Part 14 PubSub was added to the OPCUA specification, it gave a lot of possibilities where previously it was just used for ERP solutions, or where it's going from machine to the cloud. But for machine to machine communications, it was there was no possibility. So OPCUA itself now has multiple transport layer protocols. So it can work in client server model, it can work with MQTT, it can work with PubSub. So even MQTT, PubSub. So even with PubSub, there are multiple transport protocols, MQTT, raw Ethernet, and UDP. So raw Ethernet is like fast because it can surpass the TCP/IP stack, so that it's more faster. So for example, we will be seeing a motor control demonstration today. So for motor control, we need to go for cycle times less than 250 microseconds or some. So we need a faster cycle time. So client server model cannot go for this kind of a cycle time.
What is the reason for that? Why does client server model?
It relies on TCP/IP. So TCP/IP itself has its own timing requirements, and it's a connection-based protocol. So when we are going for a lower cycle time, connection-based protocol will not work. So for example, PubSub over MQTT will not be good for motor control applications. So we need PubSub over UDP for motor control applications, or PubSub over Ethernet. So
just to get a glimpse of it, that means there's some overhead concerning the connections. Whenever a client connects to a server, it has to call the server, hey, I'm connecting to you, and the server calls back, yes, you're connected to me. And you have some additional communication paths you don't want to have, actually. Concerning MQTT, that's not really the case, is it? Because you have that publisher side, that side where the topics are published on the server side, and the other client side which just receives.
Yeah, the problem with MQTT is there is a broker in between. There's a broker middleware in between. So we need to talk to the broker, and then the broker again comes into the picture. So I would say MQTT will be good for the applications which is more than 10 ms or 50 ms. Maybe a temperature sensor is very good. So for example, if we have a light sensor that we want to say whether the light is switched off or on, it's not going to be real time, right? It's even we are getting a mosquito message for every 50 ms or 100 ms, it's fine. But for robot, it's less than 1. We are going for sub-millisecond cycle time. So there, having a middleware is the overhead, and that would cause a lot of problems.
I see. What does real time mean? You said some cycle times under 1 millisecond. What else is about real time? Yeah, so when we talk about real time,
so having one master controller, and we are having, imagine we are having 4 slaves or let's have 3 slaves, so that X, Y, Z axis of a robot. So everybody should be synchronized. So when we send one packet, the same packet has to be received at the same exact time for all these 3 axes at the same time. So imagine if you're doing something and then the Z reaches like 10 ms later, and then the overall motion that we planned is going to be disrupted. So this is real time. So
real time means, so there's some determinism about real time, meaning that all those 4 motors have to be controlled at the same time, at the exactly same cycle times, not concerning the time of the cycle time, but the starting of the cycle time, like the synchronization. That has to be, I think that's a main problem of real time, actually. The cycle times itself, you know, when you only get to 2 millisecond cycle time or 1 millisecond cycle time, that reduces the speed of your machine, but it doesn't harm the functionality. So yes, when losing the synchronization, you harm the functionality. It just doesn't move like you planned your path.
So for the beginners or who are new to this topic of determinism or real time, so this is the best example that I give. So in a car, you're sitting and then you operate your power windows. Even if it is delayed by 50 ms or 500 ms, it's fine. Will you be okay with having the same delay for your airbag to open? It's not there, right? So this is the difference. So when you press a play button for your music, if it delays for 1 second, nothing bad is going to happen. But if the airbag opens after a second, we are facing some problems.
Yes, you're right. But I think times changed already, because waiting a second is quite not acceptable today, to be honest. But it's the same about steering. Like driving your car and steering, it's all normally there's some servo motions down there, which contains a lot of electrics, because you have all of that steering the cars can do right now. And even when you have a delay of about 100 to 200 milliseconds, that's not a good feeling steering your car. So you have to get down with cycle times also. So let's look at that stuff, because it's moving so nicely. So that is exactly what happens here. We have just let me give some idea I have about that stuff. You have a motor over there, and that resembles some axis of a robot arm, for example. And now that is moved via some control unit, which I assume is over there, which gives the positions to the motor, and the motor gets to that position within a defined deterministic time. Is that what happens there right now? And it is using OPCUA PubSub over TSN.
Over TSN, So to have an overview here, so imagine so this is like a small demonstrator that we spoke about, like one controller controlling like three axis of the robot. So we have one controller, which is a Linux box, which has a Intel i210 NIC card, which is TSN capable. So this is
that NIC card. That's a network card, actually. Exactly. So that's a network port with certain abilities to communicate fast.
Exactly. So they are TSN capable. It has 802.1 AS and 802.1 Q standards, so that they are able to place the packets like every single time on the same with jitter less than plus or minus 1 microsecond. So they are so accurate. So they are synchronized with, so we have a switch here, and then we have the end device. So why we added a switch here is because the switch gives you the capability of adding more devices here. So this is a 4-port switch. So imagine one controller, and then the other 3 ports can be used to connect more devices like this. So the same demo can be easily expanded into adding 3 more devices. So this particular device continuously sends messages to here. So for example, if I try to remove the cable from here, so I think I can remove it here. So the robot, the movement stops here. So it's so instantaneous, and then once I place it back, you can see the operation starts
again. That's a nice thing, because that makes it very clear that there's no client-server model connection stuff. Nobody has to talk about a new connection because it's just data flowing along the cable.
So to demonstrate this, like how accurate this is, so we built a Qt GUI on top of it, on top of the
Qt means some visualization stuff.
Exactly. So it's like an HMI, human machine interface. So this was done to explain to the viewers like how fast it is. So I attached a push button that goes from here to the switch, and from the switch we are having the interface here. So if I press it, you can see like how fast it is. So there is no lag.
It's fast. It's fast for humans, actually.
So it's faster than humans. So so this gives you an overview about how we can do it. And also what we have done is, so this robot is doing some actions in a speed, and also we have integrated client-server communications for a configuration. Now it is spinning, doing some actions at a certain speed. So if I try to increase the speed here, so you can see the motor is...
But that's communicated via the client-server model. So because that's sufficient.
So this is like... On top, everything is PubSub, and in the bottom, like we have done to show that even client-server model is possible. So this explains that how we can move something on the factory floor level, and then you move everything, and then you get it on a cool GUI, and then you're able to see what is really happening, and then everything is just one protocol from the factory floor to the cloud.
That's the main idea of that OPCUA stuff, now combined with TSN to give abilities to have real-time access also. So let's talk about those graphs over here, because right now everybody sees those graphs on some TSN overview shows and whatsoever, but I think most people don't really understand what's that all about.
So this shows that always the real-time traffic is allocated some time here, and then
at some time, that means that's kind of a bar of timestamps, and now we see that that purple stuff is
Is
always at
always-
about 650 microseconds
So we have given one
after the start of a communication slot.
Yeah, so I think viewers who are new to TSN, they can see our first video, which you can share a link. We have explained, we have spoken for 20 minutes about the basics. So this is like a bit more advanced demo since we spoke in last March, I guess. Yeah. So you can see this is the jitter graph, like how the packets are coming in. So you can see this anomaly is detected because we removed the cable and that anomaly was detected here.
Awesome.
Yeah.
That's great. Yeah.
So that's how, so this is like a test suite that we have developed, which will enable the users to see how TSN is performing on their factory floor. Yeah.
So that's great. That other color is some other communication.
Yeah, some other communications which we have generated here. So it just loops back and then.
Okay. Yeah. Speaking about that 1 millisecond, I think you have a cycle time of one millisecond.
Yeah.
It's 1 millisecond. I suppose you have. So that would start over here, and we have a graph going until here. Yeah. And now you could have some more communication parts in there. How much information can you pack in such?
So it depends upon your Ethernet interface capability. If it is like 100 Mbps device, these two devices are GBBS. So you can stuff how much ever, even you can watch Netflix over the same network and the motor will still spin. Yeah. So we can have everything in the same network and then we are okay. But sometimes when we are going for a smaller, like 100 Mbps, then we need to plan our network more precisely to pack the packets. But with GBBS networks, even we find it difficult to load the network, even for testing, right? So this becomes difficult because GBBS is like so wide.
So rock solid. Yeah. That's something we have done also at the university, just testing to disrupt somehow the TSN communication, and we just weren't able to get it done actually. Some more questions about that switch actually. So it's a special switch. We have covered that in last time, but does it work autonomously? Meaning, do you need to configure it?
Yeah, so
you still need to configure.
Yeah, so once you buy it from the factory, when it comes, once you open the box, it is like just like a normal switch. It is not a managed switch. It is normal. It just gets the packet and then forwards it to others. So you need to do the configurations for time sync. First of all, you need to configure the parameters for 802.1 AS. You need to specify the priorities. Is it like time sync capable? So you need to click few buttons. So they have a very good interface for MOXA. And also you can also use netconf to do this download of the configurations. So whatever you're seeing, all these scheduling is done by the switch.
So that's kind of the IP address of the switch?
No, so the switch, we are doing...
the scheduling is done by the switch, I see.
Yeah, so we are doing the monitoring on the Grafana tool, like the tool which we built says like what is happening inside the switch.
Yes, I see. That's something which is not very comfortable, to be honest. Configuring that switch, that's not what the guys in the industry are used to do. They're just used to plug the cables in and get the real-time stuff working right away. Somehow, depending on the field bus you're using, but concerning, for example, EtherCAT, that's the way it works. You just plug it in and it works right away.
Yeah, so this has been always a topic in all the conferences. So recently I was in TSNA conference and then we had this OPCUA FX meeting. So everywhere configuration is becoming, so previously, since this is a fairly new technology, all the while, I think for the past 5 years, we were thinking about how the time sync would work, how the QBV would work, is it okay for the end device, what is it to the controller? So all these topics were discussed. Now these have matured to a level and where we have something working here. So since last year, you wouldn't have seen motors moving with OPCUA PubSub, but we have achieved here now. So now what you are seeing is like everybody is concerned about how we can optimize the TSN configuration. So this is becoming a huge topic, and even in the TSNA conference, we had seen like many papers being presented on the efficient way, like how it can be configured. So again, configuration is not just for the switch. So it again, we need to subdivide into multi-port end devices. So imagine so this device has like 2 ports. So if I want to connect 3 devices, I can do a daisy chain and then I can connect it. So when it comes to a 2-port, the configuration becomes more big. So when it's a bridge network, it's not going to be very simple to configure. So again, we need to have more stuff inside, like we need to integrate netconf even inside this particular device, which is like a low footprint platform, but still we need to do almost all the configuration that needs for the switch. So when we talk about configuration, switch comes on the first and then comes as the bridge network and then a single port device. So for example, this controller works as a single port device, but this is a 2-port device. Yeah. So still this topic is open, and at our company, BV Services, we are also looking at having this as a research topic, and we are coming up with an architecture, and we want to make this configuration as simple as possible. But now, as you said, it is complicated.
Okay, I see. Yeah. What are your goals for making that one easy?
Yeah, so first of all, we have come up with solutions like, for example, if it is going to be a bridge network, we want to make sure that it is end device and then it's just for the industrial automation purpose. So netconf is like for any switches, right? So we want to take up functionalities which are specific for the end device. So imagine there are like 100 parameters. We want to take parameters which are bare minimum needed for this device to work, and then we should be able to achieve it is what we are doing. So I think the next time we meet, we will have a prototype for this configuration.
Some kind of automatic configuration.
Not automatic, but still we would need manual intervention, but our next target would be to configure on the go. So
what are the hurdles to overcome the problems? Mm-hmm. Why is it so complicated? Because we are used to have switches. It's the same mm-hmm. technology. It's the IEEE standard for Ethernet whatsoever, and now it got extended, mm-hmm. and suddenly those switches supporting the new stuff don't work.
Yeah, exactly. So let me put it this way. Yes, it is complicated. The question is like why the other protocols are not complicated. Yeah. The problem is the other protocols, they worked as a separate network. If you could see the legacy Ethernet protocols, you cannot mix other traffics there. Yeah. So we had like, for example, if there is a master and the slave, it was just one switch which was able to work. But here we are integrating both the IT world and the OT world. So when you're having this traffic's mixed, it's going to be like not only the real-time traffic is on the network, but you also have all the other traffics. So this overhead of configuration will be overcome by the amount of other maintenance activity that you need to do on the IT level. So for example, previously, if you had to do like integrate your IP cam and also your imagine your robot, the robot parameters. So it's like you should have a separate network for the IT world and separate network for the OT world. So now since we are integrating, we will be saving a lot of cost, and then the networking becomes simple. So imagine for example, TSN is already well used in the automotive world. So previously we used to have like different networks for the infotainment systems and different network for the real-time stuff. Now both can be integrated. So what happens is less cabling. So less cabling is like less weight and then less maintenance. And once you have the less weight, and then you have saved the fuel, and it like whole lot of possibilities come up when you integrate both of these worlds. So the best thing that I see is the edge analytics that we can do. So for example, previously we would need edge device on the network which translates the automation world data, and then it processes it, and then it needs to push it in a different way. So now since if all the networks are together, it's so easy with OPCUA to push the data to the cloud, and then we can do the analytics and take the right decisions like predictive maintenance or batch size 1. There are like many other business models would grow up when these both worlds integrate. But it comes with a price of more configuration and other stuff.
More stuff. So do you think those real-time configurations which are needed, it's for the real-time part, it's for the scheduling of those real-time parts of the messages. Do you think that can be automated in any way? Because I'm suspecting that, because at some point, you know, when it's about EtherCAT, it's about the topology you have. It's self-consistent with that. But concerning that stuff, it's so widely open because you have that other traffic coming in. You can't assume anything. So,
exactly. Yeah.
And so I'm suspecting that it's even possible to have it configured automatically.
Yeah. So the automatically, one thing that we can do is always. So imagine you have a bandwidth of 100 Mbps. We can always allocate 50 Mbps or 25 Mbps already for the time critical traffic, and then you can let the other thing happen. So this can be something automatic, but still this needs a lot of thought. So that's why the LLDP protocol, link layer discovery protocol, comes into the picture. So it tries to analyze who are the participants in the network, and then once you get like the entire topology in your master controller that needs to configure these devices, and then the CNC and CUC concepts comes in, and there we could do some automation. But again, the possibilities are endless, but still...
But they are endless because there's that prioritization. You have priorities for every network client or network machine running in there, and so those priorities can't be assumed. You have to get it into the system.
Exactly. Yeah.
Actually, is there something which is still missing in that standard for TSN? That's something.
Yeah. So everybody when we talk about TSN, the first thing that comes to mind is cabling, and then you need to connect two devices. Yeah. So it's like always on the wired networks is what everybody imagines. But in our project, ETSN.io is our project name. So in this project, what we are also working on is wireless TSN as well. So we did some projects in it, and then we already achieved certain level of synchronization. So we have like 3 devices, and then we are able to synchronize and run some applications on it as well. So we can also take a look at it like on the primary levels of what we have done with wireless TSN also.
Okay, I see. Wireless TSN, awesome topic. How does that work, wireless? That's something I still can't imagine, because wireless means you have no cables, but you have the air to communicate along, and everybody can disturb that. You know, everybody just using his cell phone or mobile phone or whatsoever, that will disturb your communication. So how to keep up determinism in a wireless network?
Yeah, so there are 2 things here. So some topics like we keep on moving, and the line of sight changes always, and then there are a lot of variables in the picture, right? So even I was working in one project where we need to control the lights in a huge community. So we had a problem where one of our customers said that one light is not switching on every time. So our service engineer went there, and then he went and looked up on it, and then everything was working fine, but we are controlling it over wireless, over radio. The problem was one tree was growing over the years, and then the tree was just in line of sight between our radio. So the tree, so for 10 years, the light was working fine. And then when the tree grew up, and then this communication got broke up, and then this light was misbehaving. Whenever we tried to configure it, this was misbehaving. So this was one of the projects that I worked previously with wireless. So this is a different topic where it is a problem for the wireless medium itself. But we are not experts to develop wireless medium, but we are developing
technology around it.
So technology around it. So we are using the wireless medium as a black box, but we want to integrate whatever we are achieved in the wired medium. We want to translate it to the wireless medium for some at least now it can be used for some basic applications, like in a closed industrial floor, if there is a moving robot, like in a logistic floor where it needs to pick up or drop somewhere, which does a same kind of movement always. At these kind of small applications, I think our technology can be used already.
You could you could really control the motors of that moving robot, of that HEV, kind of online via the cable, via the wireless LAN medium.
Yeah. So right now,
kind of moving the same movement that modem does, but just using wireless.
So we are
as long as the medium is open and not disturbed.
Not disturbed. We are confident about that. So we have already we are sending some control signals to toggle some LEDs. So we are at that level. So still we have not progressed. So this project is still, we are having a span till June. So this is like a funded project from the German government, and still we have time till June. So our next steps, we have reached some maturity level in the wired medium. So we have already started putting work on the wireless network. So maybe we can also see a demo video now about like... Hello everyone, today we have an update. So in the last video, you would have seen just the LEDs blinking. So now we are going to see what is this setup really is meant for. Okay, so there are two slaves. So this is one slave, this is another slave, and this is the master. And the master also acts as an access point. So today we are going to see how time synchronization is possible over Wi-Fi. So this is wireless TSN is what we are going to demo today. So this is the access point. So I'm powering on the access point here. So you can see that the access point is switched on, and then the yellow lights here shows that these two slaves are connected to the access point, and the red LED is the 1 pulse per second LED. So now you can see that they are all synchronized. So even if I move it around, so I have just made this a wireless part, but these are still connected, and then you can see the terminal prints here. So once I remove the power from here, you can see they are all going out of sync, and then you can see the red LED is totally out of sync. In a matter of time, they will go out of sync. Here you can see that they are all scrambled here, and here again the red LED here is off. So once I power it on, you can also see the terminal prints on the screen. So they will start getting the signal, and then now they are connected. And then now you can see all the pulse per second are aligning. Now they are all in time sync now. And you can see this is the offset between the neighbor offset is being printed here. And this is the master, these are the slaves. And this is one very small demo about how wireless TSN works. And
now you can see the 1 PPS signal is being captured, and then the accuracy between two devices that is synced over Wi-Fi is between plus or minus, now it is -6 microseconds. Now this is a live PPS signal that we have captured in our test suite. So this is what is happening in the live. So also now you can see it is in the 5 seconds. So for every 5 seconds we are updating this graph. And also what you're seeing is the last 5 minutes caption that you're seeing. So also, Marvin, can you change it to a longer duration?
For example, 30 minutes or 15 minutes?
Yeah, maybe last 1 hour is also fine. Yeah. So you can see here we had one glitch here. When we switched on and off the system, there was a huge glitch. But other than that, it was every time it was very stable here. And also, can you switch it to last 2 hours? Yeah, so we could see it's fairly stable, and then we have captured it using our TSN test suite. So this is the, now it's over 2 hours. You can see there's just one glitch. This is to show that our test suite is capable to capture these kind of outliers in the system. So this is the accuracy that we are doing, and thank you everyone.
Okay,
Rich.
So we saw a lot of awesome stuff, and now the question is, what will you do in the future? What are you showing in the future? Like there's this SPS.
So at SPS, we are having 2 booths. So one at OSADL. So that's what you're seeing now. So I think you and your viewers have already had a preview that we will be showing at the fair. And we are having our own booth, so that's going to be a bigger demo. So where we will be showing motion control, we will be having a robot, and also we will show that our ETSN SDK, which is an OPCUA TSN SDK, can work on multiple RTOS platforms, multiple hardware platforms, and then everything else is synchronized. So we give them the OPCUA publisher, subscriber, server, and also the 802.1 stack, PTP stack. So all of them working not only with the ETSN stack, but also with other stacks like Open 62541 and other proprietary implementations as well. So we are also going to demonstrate interoperability. And one cool thing that we will be adding on top of it is our Coligo device, so which is an edge AIoT platform which does artificial intelligence kind of analytics on the edge. So this will be using the OPCUA server, and then it will be taking out the data. And for example, if the robot moves, and then for example, if I stop this motor, and then immediately you can see that there is an anomaly recorded on the analytics side. So immediately it gives you alarms, it's configurable. And also Coligo gives us a feature where you put it on the edge, and then if you have an OPCUA server running, you just connect it, and then with like few clicks, you can easily expose it to the cloud, like Amazon, or you can also do it with Azure cloud or AWS cloud. In like 5 or 6 clicks, you get it exposed like instantly.
So is that artificial intelligence part running on the Coligo platform actually in parts? So it's the inference which is running.
Yeah, it's not running on the cloud, it runs on the edge. So it's real-time analytics that is running on the edge.
That's another part the industry guys are always concerned about, the data. Like running it on the edge makes it it at least makes it feel more secure.
Exactly.
What about security issues concerning those real-time networks?
Yeah, so security is a topic where it's very good with client-server communication. When it comes to PubSub, it's again a difficult topic, because when you're implementing security, you need to implement for every packet that you're sending. So imagine like for every 250 microseconds, you need to, for example, in a minute, you will in a minute or 5 minutes, you will get like millions of packets already captured. So for every million of packets, you need to do these kind of security related encoding and decoding on both the ends. So this adds a lot of weight.
But still, we have that open interconnected network. So you could go through, and as long as you're on the same cable, you can hear that TSN stuff, actually, that real-time stuff.
Yeah, the real-time stuff.
So you should never do some critical information over.
Yeah, it is possible. So what I'm saying is PubSub will also offer security, but the security cannot be done on the software is what I'm trying to, since it's like done for every cycle. So you need some hardware offloading. So some crypto chips that are apart from, so this is the primary microcontroller here. You would need an auxiliary chip, or if your chip itself has a crypto engine. So this crypto engine can help us to do the security stuff for every 250 microseconds.
But you have to do that. And is that already available? Are there those?
Yeah, so there are some implementations that are available, not for the lower cycle times, but still there is security available for PubSub. But when you're going for cycle time that you're going to do for motion control, still we are in the developments of it.
I see. Because in my opinion, that's a very important part, because it's always critical information. When controlling a robot arm, it's critical information.
So for example, previously it was not a problem because OT and IT networks were separated. So once you bring both of them, then security becomes a concern, and we are already on top of it, and we are trying to come up with architectural designs for, so it's not just the software that we are going to do. We need some hardware offloading that needs to be done for every cycle. Then the load is like amazing. So the process,
that's something I can't imagine, to be honest, because like our PCs are so powerful right now that they are not able to encrypt the the little parts of information controlling that motor, that sounds kind of weird to me, to be honest. But I think it's about it's more complex scenarios actually, and not only the simple ones. Awesome. So being such a network expert or freak like you are, how to become such a guy? What did you do to get at that point where you are right now?
Yeah, so I think I started early in the internship days. One of my projects was TSN topics were already there, and then it took its own time. It's like I'm already like 10 years working on it. So I think when you put some enough time, and then you're already knowing most of the things that is happening here. And also to help people who are new, and because I'm seeing a lot of LinkedIn messages, and I'm getting a lot of mails from students, and also like people who are starting early in their career, like how to start. Is there anything that I can learn that is open source? So for them, I'm doing some guides on LinkedIn. So you can go into my LinkedIn profile, and I'm creating these small guides how they can start with MQTT first. So once they learn MQTT, which is very easy, and then they can push their data to some dashboards, which are very simple, but I made it more simple. Like you can do it in 1 hour. You can buy your own Raspberry Pi, and then you can start doing it. And then once you're familiar with these protocols that are already stable and famous, and then you can start moving to these complicated protocols which are time critical. So slowly you can do this transition, first learning the basics and then moving to these stuff.
To the more complex stuff. So does every industrial company need some network expert in the future? That's your opinion. So some guy like you is needed by any company out there.
So we want like so many people to join our company, but it's way too difficult to find it. So I think even adding this into the curriculum of the students, like when during their internships, they can take it up, and then it would take like at least 1 or 2 years. They concentrate on this, and then it would be easy for us to take from the universities to the transition from university to the industry, real industry. It would be easier. I think you have done a good job already with your.
It's kind of a problem for me because you can't get into the stuff. You can't just show the stuff and give some overview because there are so many topics to be covered right now in industries. It's a real big topic all around software, and one part of that real big software topic are networks, and then in the network topics you have still a big part of field buses, standard network technologies, talking about Ethernet and all of that stuff. But you're right, it at least gives you an idea where to start.
Exactly.
I think that's a problem, especially thinking of the future production, because we can't talk about that decent, awesome kind of high-end network stuff where you have to get into Linux programming and whatsoever, because that won't be very efficient. That's the reason why I was asking how do you automate it, because right now we don't have the people, and as far as it concerns me, within the next 10 years, there will be even less people. And that's worldwide. That's not just about Germany. That's at every place. And that problem has to be somehow tackled in some way. And the way to tackle it, in my opinion, is to automate the things. To automate production, to automate network configuration, and to automate anything which is available. Okay, awesome, Melvin. Thank you very much for talking to me again. It was very fun. To have you to talk about TSN and its future capabilities and all the capabilities you have implemented right now. Thank you very much.
Thank you so much for coming to our office again, and it's our pleasure actually to be featured. So B Services is proud to be featured in your podcast, and we want to have one more once we have everything ready and we do the product launch soon, and where people can take it. So we have like both the open source. We are not just a closed product. It's also, we are having some parts which are open source, which students can take, and which we give back to the community also. So it's not like just we are just selling the product, and we also have some things that are being, for example, this demo works on Open 62541 with our configurations and our stuff. So it's both for both the worlds.
That's great, actually, to have it open source. That's another part I think you have to do when doing software. You have to do it open source somehow. People are used to it right now, having open source. So thank you again.
Thank you.